Hey there guys, so this is the video notes for 6.3, dividing polynomials. Before we get into actually dividing polynomials, we're going to start with a little bit of multiplying polynomials part 2. So if you remember from last lesson, we learned how to find the area of a rectangle if things are given in variable form or as polynomials. For example, this has a length of 2x plus 4 and a width of 3x minus 5. Now it says, what is the area? This is different than the perimeter. The perimeter, you add up all the sides, but for area, it's length times width, where my length is 2x plus 4, and my width is 3x minus 5. Now I know how to use the box method. I create a 2 by 2 box, where each binomial, two-termed expression, goes outside. So 2x plus 4 and 3x minus 5. Then you multiply, row by column, 2x plus 3x, or 2x times 3x, 2 times 3 is 6, x times x is x squared. Really, really important, don't forget x times x is always x squared. And you multiply number by number, variable by variable. Then you move on to the next column in the first row, 3x times 4, 4 times 3 is 12, only 1x, keep the x. 2x times negative 5, 2 times negative 5 is negative 10, x, only 1x, bring it down, so just negative 10x. Then you have negative 20, because 5 times negative 5 is negative 20. Positive times negative is negative. You can write it all out here. So my 6x squared, my positive 12x, my negative 10x, and my negative 20. Then we combine like terms. I say, okay, well I know that this has an x, this has an x. There's only one term with just an x squared, so it stays the same. There's only one term with a non-variable, so the negative 20 stays the same. However, I can add 12x minus 10x. That'll just give you 2x. Or some shortcuts I end up using later in the notes. Your diagonals always end up being your like terms. So notice this has no diagonal and stay the same. This has no diagonal, stay the same. However, the 12x and the negative 10x ended up being the two terms that combine. So that's a little shortcut you can do. Something new we're going to learn in this lesson is multiplying 2 by 3 binomials, or a binomial times a trinomial, 2 terms times 3 terms. Same box method, except instead of a square box, you're now going to use a rectangular box, where it'll be 2 rows, 3 columns. Your 3x plus 5 will go on the side, your 2x squared plus 3x minus 6 will go on the top. And you do exactly the same thing you did before. Multiply columns by row, and number by number, variable by number. 2 times 3 is 6, x times x squared. Really, really important, write this down somewhere. X times x squared is x cubed. So similar to x times x is x squared, x times x squared is x cubed. So x squared times x cubed. So we get 6x cubed. 3x times 3x, well 3 times 3 is 9, x times x is x squared. 3x times negative 6, well negative 6 times 3 is negative 18, keep the x. 2x squared times 5, be careful, 2 times 5 is 10, but this has just an x squared, so you bring down an x squared, not just an x squared. 3x times 5 is 15x, negative 6 times 5 is negative 30. And once again, you can write it all out if you want, or kind of use a shortcut. Diagonals always end up being the like terms. Notice x squared, x, 6x cubed stays the same. 9x squared plus 10x will give you 19x, so that's where this came from. You added these. And negative 18x plus 15x is negative 3x. So that's where this came from. So you just combined your like terms. Negative 30 is the only non-variable number. It stays the same. So that's what happens here. On the other side, it's written kind of backwards, but you can still do your two-termed expression, your binomial on the side, the negative 4x and the positive 3, and your 3-termed trinomial on the top, 1x squared, because when x is by itself, it's really a 1, 9x, and negative 1. Multiply like normal. 1 times negative 4 is negative 4. X times x squared, we just learned, is x cubed. 9x times 4x, well, negative 4x is negative 36. X times x is x squared. Negative 1 times negative 4 is positive 4. Keep the x. 1x times 3 is 3x squared, because you have an x, so the x squares get brought down. 9x times 3, 3 times 9 is 27. Keep the x. Negative 1 times 3 is negative 3. And once again, my diagonals end up combining. So notice this is the only x cubed value, so it stays 4x cubed. However, negative 36x squared can be combined with 3x squared, which is how I get the negative 33x squared from these two being combined. Then this has an x, and they're the same variable, so these can be combined, 27 and 4x, which will give you the 31x. Negative 3 is the only non-variable number. It stays itself, negative 3. So that's how to multiply binomials by trinomials. Here are some U-type problems. The boxes are set up. This is, remember, from last time, whenever you have a binomial squared, that just means multiply it by itself. So this means 4x plus 4 times itself, 4x plus 4. This is two terms, two terms. This is our square box method, where we have 4x plus 4, 4x plus 4. Here's what answer you should get, so try it on your own. See if you can get this. Keeping in mind that your diagonals are going to end up adding to 32. Now this is a 2-term times 3-term expression. So your 2 terms go on the side, 2x plus 1. Your 3 terms go on top, x squared plus x minus 1. Also keep in mind, these diagonals will be your x squared values. These diagonals will be your regular x's. And these will stay the same. So see if you can do this on your own and get this answer. 2x cubed plus 3x squared minus 1x minus 1. So you can pause the video to try on your own, so you can get this answer. Let's move on to dividing polynomials. Now this is another area problem where they're giving you two of the sides. We know area is length times width, so 3x minus 8 times x plus 6. I filled out my box, combine my diagonals, negative 8 plus 18x is positive 10x. 3x times x is x squared. Negative 6, or negative 8 times 6 is negative 48, stays the same. But what if we were given the area? So what if we're given the answer, and we had to find the width when we're given only one of the sides? So what if I knew this, but I didn't know this? Well, you can kind of think of it if there were regular numbers, without variables. If I knew the area of my rectangle is 40, one of the sides is 10, well, if you know length times width is area, and you know you need a number multiplied by 10, that will give you 40, which means it has to be 4. Same idea. You can go backwards. 40 divided by 10 is 4. So, dividing polynomials is going backwards. They give us the full term, so they give us the answer. We know one of the binomials. We need to find the other binomial. So that's what's happening here. So we know one of the sides. We do not know the other side. This side will be our answer. So you kind of have to work backwards. First, we fill in what we know. The 2x squared is your first term. It will go in the first box. Your last term, negative 3, will go in your last box. Notice you're left with 2 boxes, but only one term in the middle. That's because you don't know these yet. They have to get split up, because we know the 2 boxes end up being combined to be the middle term. So we don't know what 2 numbers get combined to be 5. It could be 2 and 3, 1 and 5. So we have to work backwards. So you start by saying, okay, well, if I know this is 2x squared, and I know one of these is x, x times what is 2x squared? Well, I know x times x is x squared. So I need an x here to give me the x squared. I'm also missing the 2. So this is a 2x. 2x times x is 2x squared. Now that I know this is 2x, I can now figure this out. 2x times 3, well, 2 times 3 is 6. The x is 6x. Now I start to make more sense. You kind of work in this direction. So then you say, okay, well, this is 3, and I know it gets multiplied to be negative 3. 3 times what is negative 3? Well, the number is going to stay the same, so now I'm going to use a 1, but it becomes negative. So a negative 1. So this is my answer. 2x squared plus 5x minus 3 divided by x plus 3 is 2x minus 1. But let's say you want to double check your answer. We can finish out my box. Negative 1 times x is negative 1x squared. I know these will get combined. 6x, negative 1. 6 minus 1 is 5. Notice that gives you the middle term. So we did it correctly. That's one way you can check your answer. Oh, maybe I should leave it on the screen. Pause it if you need to finish writing it out. So then we move on to fractions and solving equations. This is what we've been doing before, distributing company-like terms. The only difference is that now we're adding fractions. So we distribute like normal. Since we have a number attached in parentheses, distribute is always your first step if you can do it. 1/2 times x is just 1/2 x. 1/2 times -4, well, that's just really 4 divided by 2. -4 divided by 2 is -2. If you don't know how to do that in your head, that's okay. Use a calculator. Bring everything else down. Don't forget your +2 and your equals 3. Now you're going to combine like terms. There's only one number with an x, but there's a non-variable and a non-variable. These can be combined. -2 plus 2 actually ends up canceling out. So you end up with 1/2 x equals 3. Now be careful. A lot of times students always assume they're going to divide by 2 as their last step. In this case, you have 1/2 x. 1/2 x, well, to get rid of that 1/2, that 1/2 means divide. So the opposite is to multiply by 2. That'll leave you with x equals 6. So be careful there. Same idea here. It's a little bit harder when you have a numerator instead of just a 1. So we'll distribute. If you don't know how to do that, you can use a calculator. So 3/2 times 2 is +3. Don't forget the x. 3/2 times 6 is +9 with no x. No x, no x. And bring everything down. The minus x equals 13. Oops. Minus x equals 13. And I know when an x by itself, it's a 1. Now these are my like terms. 3x and -1x. Well, 3x minus 1x is just 2x. The 9 is the only non-variable on this side, so it stays the same. Then this is just a 2-step problem. Subtract 9 from both sides. You get 2x equals 4. This time, x is being multiplied by 2, so you're going to divide by 2 on both sides. Make sure you know when to multiply by 2 to cancel out versus when to divide by 2 to cancel out. You have a few try problems that you can try on your own. So, I'm going to do the top 2, the bottom 2 you can do on your own, just so you can have more practice with dividing polynomials. Once again, your first term is always the first thing that goes here. Your last term is always the last box. This one's a typo. It should be x minus 2. So cross that out. It should be x minus 2. And work backwards. X times what is x squared? Well, we know x times x is x squared. -2 times x is -2x. -2 times what is -2? Well, the number is the same. And the sign is what I want. So +1. That's your answer, x plus 1. But we can check. 1 times x is 1x. If I check my diagonals, 1x minus 2x is -1x. We did it correctly. Last time to work backwards, we know x times x is x squared. 3 times x is 3x. 6 times what is 6? Well, 3 times 2 is 6. But you want it to be a -6, so a -2. That's your answer, but let's check your answer. X times -2 is -2x. 3x minus 2x is +x, or +1x. You did it correctly. Try the last one on your own. Here's what you should get. X plus 4, x plus 6. And you'll fill these out at the top. And I guess I can start helping you out with this one. since it's slightly different. We know x times x is x squared, but there's a number this time. You have the number here. So you just do 1x. 7 times 1 is 7, x times x is x squared. And then you finish off like normal. Notice 1x is the same thing as x. That'll be negative 9x. Negative 9 times what is negative 36. The sign is correct, so let's be positive. Negative 9 times 4. That's how you get x plus 4. And then you can check this out. For this one to go a little bit faster, x times x, negative 3x. Negative 3 times what is negative 18? Positive 6. Positive 6. Oh. Negative 3x plus 6x is 3x. So those are your answers. If you have any questions, feel free to sign up for tutoring.